Good. Audia, unasikiza vizuri? All right, all right, all right, all right. Thank you, everyone, and welcome to our class. We are introducing Haccp. I think I'm introducing Haccp. I don't know for how many times. I've done this again and again, and I think the more you do something, the more you understand it. I don't know. Maybe after this class, you'll be able to tell me. Do you like it when you repeat a session for long, or you don't like it? Anyway, for me, welcome to this class. This is Haccp, and we are going to start straight away with what Haccp is. But before we talk about what Haccp is, you need to understand first what food safety is, because we can never have Haccp without food safety. And food safety is the assurance that food will not cause any adverse health effect. And you're just sure that the food we are consuming, or the food that is being consumed, at the end will not be able to cause any adverse health effect to the consumer, that is. And this one, you should be able to mention that it is only when prepared and eaten according to its intended use. Because nowadays, if you can go to TikTok, you'll find people trying to eat things which are not meant to be eaten. So, or they are preparing things in a way that should not be prepared, or in that way. So, food safety is the assurance that food will not cause any adverse health effect to the consumer when it is prepared or eaten according to its intended use. When it is eaten and prepared according to its intended use. All right. One of the most common, one of the Haccp is becoming one of the most used approaches that have gained global recognition. Um, uh, is the Haccp system. Now, in the food safety industry, or in the food safety in general, Haccp is one of the things that has been able to gain global recognition. It has been applied nearly everywhere, and we are going to see nearly all the countries across the world are currently recommending the use of Haccp in every food system. So Haccp is an acronym for Hazard Analysis and Critical Control Points, and normally pronounced as HACCP. HACCP. It is normally pronounced as HACCP. It is a systemic approach to achieving food safety. So the most important thing for you to understand is it is a systemic approach to achieving food safety. And not only that, but also it is this is whereby you are going to identify, you are going to evaluate, and finally you are going to control the food safety hazards. So here we're talking about hazard analysis. So we need to understand what this word hazard is, and what exactly a hazard and a risk is, because we are talking about hazard analysis. Hazard analysis. What is this hazard? So before we talk about that, we need to understand how did we came up, or how did we end up having hazard? How did we end up having hazard in place? So in the early 1960s, there was a company called Pillsbury Company. Pillsbury Company was doing some assignments for the NASA, that is National Aeronautic and Space Administration, and also the U.S. Laboratory Armies. Pillsbury Company was a company that was designated to produce food for the army. You see, so food that was meant to be given to the people who are in the army was being produced by a company called Pillsbury Company. So one of the people during those times in the 60s, explorations were one of the key things, and people used to do a lot of explorations. That is why now we had people we refer to as astronauts. These are the people who could go to space and check. For example, somebody is traveling to the moon, somebody is doing this and this in the space. So those people who are going to the space, we refer them as astronauts. They were carrying food to space. So when they carried food, it was very important for that food to be safe, to so that that food will not be able to cause any effect to their health. Because if there will be anything, or if there is any issue with the food, or any possible case of food poisoning in the among these astronauts, it could be very serious both to their lives and to their mission. Two things: the lives and the mission of these people could be at risk if they consume food which are not safe. So in the early 60s, as a measure to ensure food safety or safety of the astronauts' food within the US space program and to prevent food poisoning which might arise when consuming unsafe food, the company, that is Pillsbury Company, was tasked with the task of coming up with a system that they could be able to use to be able to ensure safety of the food. So the idea behind the Haccp at this time was to study every food production step and to identify the potential hazards at each step with the establishment of the necessary measures to control. You see, you had to be able first to know what is happening in every step. The step-by-step production process of this food. That was number one. And for every step, you needed to identify. If you can recall what I told you, it's a systemic process for identifying and sorry, I said this is a systemic approach. For first you need to identify, and then you evaluate, and then finally you try to control, put them under control. So the first thing here was to know the step you are involved, and then you identify the potential hazard at this step, and then you establish the corrective measures for that hazard at that step. You see, so in 1972, Pillsbury Company, upon request by US FDA, that is the US Food and Drug Administration, held the first training that was named Food Safety Through Hazard Analysis and Critical Control Point System. Food Safety Through Hazard System, with a focus in canning industry. You know, even in Kenya here, the people in the army consume a lot of canned foods. So Bill's Parry Company was one of those companies that developed Haccp because they were producing canned food. So Bill's Parry Company, upon request by FDA, was able to develop a system and start the trainings. And the training title was Food Safety Through Haccp System, and the main focus was on food canning industry. So now after 1960s, and by 19 we are talking about 1972. Now in around 1993, we had what is referred to as the Geneva Declaration. The Geneva Declaration, which incorporated the guidelines for the application of a subsystem. It was adopted in the 20th session of the Codex Alimentarius that was held in Geneva, Switzerland in 1993. That was the first kind of revision that was there. The adoption of the guidelines for the application of Haccp into what we refer to as the 20th session of the Codex Alimentarius, which we sometimes refer to as the CAC, or what we refer to as CAX. So this led to the inclusion of Haccp approach as an annex in the general principles of food hygiene. That is revision number 2 now. That was the second revision. That Geneva Declaration led to the inclusion of the Haccp approach as an annex in the general principles of food hygiene. And that is the second revision of 1997, and this continued the third revision of 2003. So the 2003 revision was all about what they refer to as editorial changes to the document, editorial changes to Haccp. Now, it was not still independent. It was relying on food hygiene. So every time you needed to talk about food hygiene, you needed to refer to Haccp. Or every time you talk about Haccp, you need to get more information from food hygiene. So it was not still independent. Not until recently in 2020 that when Haccp was incorporated in the latest revision, that is revision number 4, as an independent chapter. So well, after 2020 now, we can be able now to say such and such a company is registered, and maybe this company is Haccp competent, is Haccp certified. That is 2020 and beyond. So beyond that, before that, there was nothing much, nothing less. Good. Okay, so nowadays Haccp has gained global concern. I told you it is gaining global recognition, and the application of Haccp system has become mandatory in many countries of the world. And as the Haccp system is now globally recognized, this has encouraged the international certification bodies to consider it as a core in their food safety management system standards. So, for example, we are talking about food safety management, the FSMS, So FSMS, we have several FSMS. For example, we are talking about ISO 22000. ISO 22000 is a food safety management system, and uh, in the latest revision, that is version number ISO 22000 2018, the 2018 version, it has Haccp in the eighth, what do we call it? What do I call part number 8 of ISO 22000. It's barely talking about the acting part of it. So that one is it's being able to incorporate ASAP as the core system. Now, FSSC 22000 on the other hand is based on ISO 22000. So you see now the link. FSSC 22000 is based on ISO 22000. ISO 22000 can never be ISO 22000 without the Haccp, which is the core part of that food safety management system. So in so doing, that is what we are saying here. It has gained global recognition. Even the British Recognition Consortium, the BRC, has also incorporated the aspects of Haccp into its system. So ensuring that the whole of this system is complete and working, because we have Haccp, which is a systemic approach to achieving food safety. So any food safety management system is basically, we are saying, any food safety management system should be based on Haccp analysis, because Haccp analysis is a systemic approach to achieving food safety. I hope we are together. Good. And what are the benefits of food manufacturers, or hazard benefits to food manufacturers? Number one is it's a way of gaining confidence of the consumers and the competent authorities. Like now, if I know today that such and such a company is hazard competent or is hazard certified, I'm good. That is the best thing that can ever happen, because I'm sure that this company is producing safe food, because HACCP is a system that ensures safety of the food. Number two, HACCP helps food companies to compete in national and international markets. Like for today, if you want to maybe export your food product, it's very important. You will be asked, can you give us a HACCP plan for this food product you want to export? For example, if it's milk, you're asked, give us the food as the HACCP plan for this milk, and how do you produce it and everything. So all that is being considered and is going to be detailed in a HACCP plan for that specific product. So it also minimizes the risk of unsafe food production. You see, it minimizes the risk of unsafe food production, because we are going to follow step-by-step guideline. So it is going to minimize the risk of unsafe food production. And apart from minimizing the risk of unsafe food production, um, this one will reduce the cost of production, because there will be no issues with recalls or inferior quality standards, because you are following this process step by step. So there will be no issues with that. This product did not meet the requirements after production. No, you are going to follow a step by step process. So if you are going to follow a step by step process, then at the end of the day, you are going to reduce the cost of production that are related to recalls and inferior quality. It also helps food companies to gain good reputation and consumer confidence, like just as I mentioned in the first point. And finally, it helps food companies reduce the high legal and compensation or an insurance cost. For example, if today I consume food, I think recently, or for last month, I was in Eldoret, and I happened to have I was in one of the hotels in Eldoret, and it happened that one of my colleagues had food poisoning, maybe due to the food that we consumed that night. And after we came, we launched a complaint. After the complaint, you see now the insurance cost. My colleague had to go and seek medical attention, and he used, I think, close to around 40,000, and that money was compensated by the hotel in totality, in full, because this food poisoning was because of food that was consumed in the same hotel. So if at that hotel, for example, could have been using ASAP, they could have reduced those costs, because at the end of the day, there could be no any compensation they were doing. But for now, they have consumed, they have produced food. The food has caused food poisoning to one of their customers, and at the end of the day, the customer has lodged the complaint, gone through all the legal requirements and all the legal process that you are required, and at the end of the day, she received her compensation in totality. So that is why we are saying Haccp is important, because it's going to reduce the high costs, that is legal cost, compensation cost, and insurance cost. Good. All right. Now we are to something I was mentioning to you previously: hazard or a risk. Which one is which? What is a hazard? What is a risk? So, a hazard and a risk are two terms that are commonly used within the same discipline of food safety. A hazard basically is any biological, chemical, or physical factor or agent in food with the potential to cause adverse health effects. If you remember, we said food safety is the ability of a food not to cause any, that like the assurance that food will not cause any adverse health effect. So if there is something in that food that can cause the adverse health effect, then that thing in that food is what we refer to as a hazard. For example, the thing in the food that made my colleague get food poisoning is exactly what we are talking about here as a hazard, because it could either be biological, it could either be chemical, it could either be physical, or even allergens. Nowadays we have a fourth type of hazard which we refer to as allergens, and we are going to talk about this in length. Okay, just to introduce this thing, risk, before we continue. A risk is the probability or the likelihood of a hazard being present in a specific food along with the severity of such a hazard. The ability or the probability of a food being present. Not only probability, but also the severity. So we normally say risk is a function of the probability and the severity. So if you want to write risk in a equation, you just say risk is equals to probability times the severity of a hazard. For example, how likely is this food to have of this hazard to occur? How likely of this hazard to occur? The likelihood of occurrence, the probability of occurrence. That is one. Maybe it is low, medium, or high. There is high probability that this food will be there. And if it is going to be there, how severe will this hazard be? Will it be high, very severe, low, or medium? So now, maybe low, high, and medium can be represented by 1, 2, and 3. And the severity also can be represented by 1 to mean low and 3 to mean high. So we will say the risk is equals to now probability, maybe high, 3, times the severity, maybe severity is 1, maybe it is low. So 3 times 1 is 3. So the risk is 3. So if it is 3, we have what we refer to as risk assessment, which we are going to talk about in not so long from this slide. Good. Let's now first talk about the hazards. I told you we have 4 types of hazards: biological, chemical, physical, and allergens. Biological agents, we have these are any living pathogenic organism that can be present or be introduced to food, which in turn poses a threat to consumers' health. Any living pathogenic organism, anything. Pathogenic means disease causing sometimes. Pathogenic means disease causing organism that can be present or be introduced to food, which poses a threat to the consumer's health. These ones can be classified in 4 main categories. One, it can be either be bacteria, for example, Escherichia coli. It can either be viruses, for example, bacteriophage. It can either be parasites, you see, or even prions. And for the people maybe who don't understand what prions are let me call them, they are abnormal growth in what we refer to as the prion proteins, which are found in the brain. And it normally causes a disease which we refer to as the Creutzfeldt-Jakob disease in human, or what you refer to as the mad cow disease in animals. But the disease in humans is called CJD, Creutzfeldt-Jacobs disease. You can be able to read more about that in the maybe the slides that will follow, or not even the slides, in some reading materials I'm going to share in the WhatsApp group. The reading materials that I'm going to share in the WhatsApp group. Good. That was basically that was the biological agents. And actually, biological agents, another example of biological agents is what we normally refer to as what do you call gamma rays. You see these rays. For example, the aspect of people telling you do not microwave things. When you microwave, you'll have those gamma rays. Those gamma rays are examples of what we refer to as biological agents. It's a long story, but maybe that story we can be able to talk about in another day. Now, let's talk about the chemical hazards. Chemical hazards are chemical compounds or substances that, when are present or introduced to food, will have the potential to cause adverse health effects to the consumer. Anything, any chemical substance, compound, and this one can either be naturally occurring, for example, cyanide in cassava, naturally occurring chemicals, intentionally added chemicals, for example, peroxide in milk, unintentionally added chemicals, for example, cleaning agents in food, environmental contaminants, for example, smoke, food processing induced chemicals, for example, preservatives. All those are what you refer to as the chemical hazards. Chemical hazards. Are we together, class? Yes, good. Those were chemical hazards. Let's talk about the physical hazards, which is the third category of hazards. A physical hazard is any extraneous object or foreign matter which, when introduced to food, may cause illness or injury to a person consuming that food. Any extraneous object. This one now is physical, something you can be able to see. Extraneous object or foreign matter, which, when introduced to food, may cause illness or injury. In this case, mostly it's an injury to a person consuming the food. Examples are, for example, glass fragments in food. Glass fragment. Maybe you are handling, for example, you are carrying a test tube in a production room. Maybe you are taking some samples, and unfortunately, the test tube breaks into the food. That will be a physical hazard. Human hair. That is why we are asked to cover our head and wear protective, the PPEs, the protective equipment, because we don't need human hair in food. Nails, dirt, stones. I think stone is one of the common ones, especially. I don't know if it is me alone who is having that phobia, whereby if I'm eating food, for example, rice, for example, beans, for example, kideri, if I consume kidogo, if you hear some, maybe you are consuming the food and all of a sudden you bite a stone. I know most of us are, we might even injure our tooth because of the stones. So, very sensitive. Pieces of jewelry. That is why you are not allowed to wear jewelry whenever you are entering into a production room. Metal containers or even frilled toothpicks. All these are examples of what we refer to as the physical hazards. Let's now talk about the last category of hazards, which is called allergens, which is referred to as allergens. So allergens are any abnormal immune response to sensitive segments of people, not everybody, sensitive segments of people, against a particular protein, in this case, allergen, which is always accompanied by production of Ig antibodies. So, get it clear here. It's any abnormal immune response in the sensitive segments of people against particular proteins. So one thing you should know is all proteins are not allergens, but all allergens are proteins. All proteins are not allergens, but all allergens all allergens are proteins, not that. So any abnormal immune response to sensitive segments of people against a particular allergen is because of the presence of in that thing or in that food, maybe it contains an allergen. Let's give an example. I want you to look at the picture on the left hand side of our slide. The first picture is about wheat. Wheat is because of the presence of what we refer to as gluten. And people, some sensitive segments of people are sensitive to gluten. Number two is a packet of milk. Some people have what we refer to as milk allergies, leave alone what we refer to as lactose intolerance. No, that is about lactose, not proteins. For any allergies, it's all about proteins. So when you talk about, in this case, maybe milk, we're talking about milk allergies because somebody is allergic to milk proteins. I hope we are together in this. Number three is eggs. Number four is fish. Number five is what we refer to as ground nuts. Ground nuts. Jugu. Number six is what we refer to as soya. Number seven is what we refer to as tree nuts. Example is macadamia. And the last one is what we refer to as seafood. For that example is grape. All those are examples or categories of what we refer to as allergens. These are not the only ones. We might have even more than that. Those are what we refer to as allergens. An allergen reaction is an abnormal immune response to sensitive segments of people against a particular protein, in this case, an allergen. And we said all allergens are proteins, but not all proteins are allergens. Good. That was done with the hazards. Let's now get to risk. What's risk? As we said before, risk is composed of two elements. The first is determining the probability of the presence of such a hazard in food. And the second is knowing about the severity of injuries or even death death cases that might arise from such a hazard. So just know a hazard is the probability times the severity of the hazard. Risk is the probability times the severity of a hazard occurring. So that is all about hazard and risk. That is all about hazard and risk. Maybe a few things I need to mention before we get deeper into hazard is what are SOPs, and these are standard operating procedures, and these are the things that are just helping us to ensure that we observe the right procedures in handling food. So it has nothing more, nothing less. Just know that SOPs are written practices or procedures that are important for producing safe food. It is essential to have these SOPs in place, to have all food handling personnel trained to use them. So these ones, I'm not going to dwell much on that, but I'm going to go deeper into now Haccp. So we've known what Haccp is. We've known that Haccp cannot be complete without talking about food safety, which is the assurance that food will not cause any adverse health effect. And Haccp is here is a systemic approach to ensuring food is safe for consumption. So how does Haccp works? Haccp plan is a 12 steps thing, or just Haccp in general follows a 12-step rule. In the 12 steps, the first 5 steps are what you refer to as the preliminary or what you call preparatory steps. You are preparing yourself to develop a Haccp plan. So there are things that you need to do in preparation. These are the theoretical things. You are not in the food industry. You are outside. You are just doing the theoretical parts first before you get into the deeper things. So the preparatory steps, or what you refer to as the preliminary steps, are the first steps, the first 5 steps that ensures food is safe for consumption, or that ensures us in development of as a plan. So let's now get into these first 5 steps. So before the application of the Haccp principles, the 5 preparatory steps have to be conducted before the application of the principles. I know you all know that we have the 7 principles of Haccp. So before we talk about the 7 principles of Haccp, we have the 5 preliminary or the preparatory steps which we need to follow. Number 1, assembling the Haccp team and identifying the scope. Assemble the Haccp team. This is the team that is going to help you develop the Haccp. So the Haccp team, we are going to talk about in depth, should comprise of everybody, both in management, both in production, both even the consultants. You should have a wholesome team. Even the team in what you refer to as maintenance. Everybody in the industry should be represented. It should be inclusive as much as possible. Identification of the scope is, in an industry, we might be having up to 10 products at once, or 3 or 4 products at once. We need to zero into one product. So we are identifying the scope. We are identifying the product that we need. That is number 1. Number 2, you need to describe that product. Now you have assembled the team. You have identified the product. For example, in this case, maybe yogurt. Let me give an example of yogurt. Do I give an example of yogurt? No. Let me just give an example of pasteurized milk. You see? Let me give an example of pasteurized milk, because maybe if I give an example of yogurt, maybe some of you might not be in the dairy industry. Let me just give an example of pasteurized milk. So you have identified the team, you have identified the product, pasteurized milk. Now describe that product. If you are describing the product, you need to tell us what are the raw materials. What do you have in this? What do you have in this? Several things in describing the product. Once you are done with the description of the product, you now identify and tell us what is this product we are making used for. If it was yogurt, tell us yogurt is used for maybe by even lactose intolerant people. That is the users. The use, maybe it is, I don't know. Whatever the use of that product you are preparing, you need to write. Even the users. Recapitulating patients. Lactose intolerant people. All those. Number 4, you construct the flow diagram for that product. How do you produce the product? All the way from raw milk reception, all the way from dealing with the raw materials, all the way to finished product. Draw the flow diagram. After drawing the flow diagram, do what we refer to as on-site confirmation of the flow diagram. On-site confirmation of the flow diagram. So you need now to go back and check. Did what I said, did what we write in the flow diagram, is it exactly? Have we omitted any step? Have we added any step? Is there any step that is unused? All those are what we refer to as confirmation of the flow diagram. Let's get into one by one. Step number 1, assembling the Haccp team. This is the group of people who are responsible in developing and implementing, maintaining the Haccp system within a food manufacturing organization. This is the team that is responsible for developing, implementing, and maintaining the Haccp system. Just know that. This team should determine the scope of the Haccp as well as any prerequisite programs that you might need. It will also specify which types of food that is being processed within the establishment and the procedures used as well. That is step number 1. Basically, these are the people and what the product and the products we are dealing with. Step number 2, describe the product. So this a complete description of the product should be created. For example, the origin of the raw materials, which may help recognize certain hazards, relevant safety information such as the composition, the physical chemical properties, processing methods, technologies, packing, durability, shelf life, storage condition, methods of distribution. This one, if you look at this diagram, at this slide, you might think this is a lot of things we are needed. When we'll be dealing with a live example in our next class, it's going to be very simple. You are just studying what are the chemical properties of, for example, milk. What are the physical properties of milk? What are the biological properties of milk? You see, if you don't have any biological property, you just say none. You see, and move forward. The packaging, are you using plastics? Are you using glass? You see, durability, what is the shelf life of this product? You see, storage condition, should we keep under refrigerated conditions or how do we transport? So all that is what we refer to as the description of the product. We describe the raw material, we describe the finished product. The raw material and the finished product. All that is what we are needed to describe. Step number 3 is to identify the intended use and the users. So you should be able to identify the normal or the expected use for each product as well as the expected users of this product by the next user in the food chain or the consumer. This one tell us this product, how will it be used? Is it a ready to eat food? Should you subject it to further treatment? All that. The product description may be influenced by the external information, such as information from regulatory authorities, the competent authorities, other sources on ways in which consumers are known to use the product. Maybe for example, nasikia sijui asali inatumika sijui kama dawa. So maybe in your uses, you might mention that and tell us this is from this source. So that is it. Step number 4 is constructing the flow diagram. Now, Drew, tell us from reception of the raw materials, what's the next step? After that, what's the next step? After that, what's the next step? What's the next step? All the way to the end. So this is a flow diagram can be defined as a systemic representation of the sequence of steps used in the production or the manufacture of that food. When preparing for the application of the hazard food system, a flow diagram that encompasses all the processes in the production of a certain food product, including any applicable work, should be constructed by the hazard team. Now, you have a team in place. Kazi yao sasa ni kukaa chini, hii kitu tunatumia kufanya nini? Hii step number 1. Ukimaliza hapa unaenda wapi? Ukimaliza hapa, and that is why I was telling you it is important to have everybody on board. If you have somebody who is doing production, have that person to explain to you how step-by-step production process of that particular food. We are going to see that in our next when we deal with the example. Step number 5, and which is the last step in the preparatory steps, is what we refer to as on-site confirmation. After the flow diagram has been constructed, the HACCP team should take the necessary measures to confirm the actual and on-site processing activities against the flow diagram at all stages and hours of food processing operation. You should consider 1, that all food processing steps are included. That is number 1. Number 2, you should ensure that steps and operations are shown in the correct order. Number 3, steps or processing or handling operations, there is no step or processing operation which is missing, and no unused step is present in the diagram. Those are the things you need to check to confirm, or what you refer to as to do what you refer to as on-site confirmation of the flow diagram. If you can be able to do that from step number 1, step number 2, step number 3, and finally step number 4, then I can be able to tell you, and I'm confident that you can now proceed to the next level, which is now incorporating the 7 principles of HACCP. So the 7 principles of HACCP. So after we have completed the preparatory step of the HACCP, food safety systems, which include the prerequisite programs and the 5 preparatory preliminary HACCP steps, now comes the time to implement the principles of HACCP. So the HACCP food safety system has 7 principles or steps that have been fully applied in the correct order, that have to be fully applied, not only fully applied, but also in the correct order. I want to maybe pause and ask a few questions, maybe. All right. So the 7 principles of HACCP. So now let's get going. Principles of HACCP, there are 7. Principle number 1, conduct hazard analysis. Principle number 2, identify the CCPs. Number 3, establish the validated critical limits for each CCP. Now we are talking about critical limits for now each CCP. Number 4, establish a monitoring system for each CCP. Monitoring who, what, when, how. Number 5, establish corrective actions. Number 6, validation of the hazard plan. And number 7, establishing documentation and record keeping. And has to go very straight into this because there's nothing much to talk more about this because we'll be dealing with this more with the example. It is important to deal with this when we have an example in place. Principle number 1, conduct a hazard analysis. So, hazard analysis is the term used to describe the process of collecting, evaluating the information of hazard associated with the food under consideration to decide when the significant and must be addressing the hazard plan. This is we are conducting hazard analysis. So, the first thing is, or how you can be able to do this is first listing all the relevant potential hazards and the identification of their control measures. For example, we have developed a hazard plan, a flow diagram for each step. So now you go to step number 1. Tell us the potential hazards that can be there and the control measures. So you tell us the step, control measure, and the step, the hazards, and the control measure. Step 1, tell us what the step is all about. Describe that step. Tell us the potential hazards in that step. And lastly, tell us the control measures for that step. And I'm going to use a very good example, which we are going to deal with that in the next class, and you'll be able to see how these principles come in. First, if it is all about identification of the step 1, so you draw it in form of a table where the first column is the step, the second column, description of the step, the third column is the hazards in that step, and the fourth column is the control measure. So you'll have like 4 columns. First column is the step, second column, description of the step, the third column is the hazards in that step, and the fourth column is the control measures. Then you come to the second one, identify the CCPs. So in the identification of the CCPs, now a CCP is a step in which control measures has to be applied. This is the point, or this is the step in the production process where a control measure has to be applied. That is a critical control point. This is the point, a step in the process at which control measure or measures is or are applied to prevent or reduce significant food safety hazards to acceptable levels and defined critical limits. So the next step, that is principle number 3, is talking about the limits. So I'm not going to talk about the limits. But first, just know you need to identify. How do you identify the steps? You have 2 ways. One is by means of what you refer to as a decision tree. The second way of identifying CCPs is what we refer to as the risk assessment or the risk level assessment. So under decision tree, use what we refer to as the Codex Alimentarius decision tree. A Codex Alimentarius decision tree, or what we refer to as HACCP decision tree, has 4 steps. 4 steps or 4 questions. If you can check in our diagram, we have question 1 to question 5. But question 1 is not always there. That question 1 is not, we don't normally ask that question 1. So we always start with question 2, question 3, question 4, and finally question 5, which now at decision 3 should have 4 questions. So if you ever go to an interview and you be asked, a Codex decision 3 should have how many questions? You should tell us it should have 4 questions. So you should have 4 questions. And the first question should be, Are control measures in place for this hazard? If yes, proceed to question number 3. If to question number 2. If no, modify it in such a way that it gets back to the answer. Because if there are control measures, then it is not a CCP. You see? And if the control measures can be applied elsewhere, then you need to modify the step. So question number 2 is now, is the process step specifically designed to eliminate hazards? If it is designed to eliminate the hazard, then it is a CCP. If it is a no, then you can proceed to the question number 3, which could contamination occur further? If yes, will there be a subsequent step? If there will be no subsequent step, then that's a CCP. If there will be a subsequent step, then it is not a CCP. I know most of you are food scientists and you understand this Codex Alimentarius Section 3 better than even I do. The second way of identifying CCP is what we refer to as risk level assessment. Risk level assessment is just what I was talking about in risk. It is the likelihood times the severity. Likelihood times the severity. So for example, in our example here, we have rare, small, medium, and high. So we have four outcomes. It can either be rare, it can either be medium, or high. It can either also be negligible, moderate, serious, or very serious. So if you want to know which one gets into a decision tree, if you want to know which one can be a CCP, just do this. Take 4, because we have 1, 2, 3, 4, rare, small, medium, high. And then also we have 4 on the other end, negligible, not negligible, but negligible, moderate, serious, and very serious. So if you have 4, you just say 4 times 2, 8. So 8 and above, which in this case gets into the red line, the red zone, becomes automatically a CCP. And you need to take it to a decision tree for further scrutiny. If it falls between the yellow line, then that one is not a CCP, it is moderate, not serious. If it is between the green side, then it is not serious and it is very negligible. So every time, maybe you have a risk level score which has 3 things, 3 scores, 1, 2, and 3. So you just say 3 times 2, which is 6. So 6 and above will fall under the CCP, or what you refer to as, it can be further taken to addition 3 for further scrutiny. I don't know if that is clear. Organisms, for this case, maybe for Clostridium putilina, maybe that is the target microorganism you are targeting. So the likelihood of you not achieving might be high. For this case, maybe it is 3. You see? But now, what does if it occurs? It will be very serious if it does occur. So if it is very serious, so you say 3 times 4, because severity is 4, very serious. So 3 times 4 is 12. So if you check 12 in our table, it's falls in the red zone. So if it falls in the red zone, then that tells you it is a CCP. That step is a CCP. Or it can be taken for further scrutiny to confirm whether maybe it's a CCP or an OPRP. Because some of the steps can be an OPRP, Operational Prerequisite Program, which you are going to talk about that. So I was telling you, in short, even without having a table, just say, if it is 1 to 4, just say 4 times 2, which is 8. So 8 and above falls under the red zone. Anything below that cannot, anything 8 and above will fall under will automatically be taken into further scrutiny, because there is a high likelihood that step is a CCP. For example, now, if you do, for example, maybe reception, maybe the likelihood may be even very rare, and the severity might be moderate. So it is 1 times 2, so it is very small, so negligible. So if you only have scores of between 1 to 4, just know it's two times the high score, which is 4, is 8. So anything above 8 falls under addition 3, or is most likely to be a CCP. I don't know if out there you have gotten that. Out there umepata hiyo? Susan, umeelewa hiyo? Good. Chepkorir, out there bado? Umeelewa sasa? All right. But you can always feel free to also get reach back to me and ask me if you have any issues with that. Good. Let's move to the next thing, which is principle number 3. You now establish the validated limits for each CCP. And in most cases, a CCP will always have limits. For example, if it's a pasteurization, we always have what we refer to as the time temperature combination. For pasteurization, it can be maybe 72 degrees Celsius for 15 seconds. Those are the limits. So you establish the limits which are acceptable. A limit is a criterion observable, measurable, relating to the control measure at a CCP. We separate acceptability from unacceptability. Anything that separates the two is what we refer to as a critical control, a critical control limits, or a critical limits for this matter. Principle number 4, establish monitoring. So you need to monitor now. So in monitoring, you need to be able to bring in to aspects of sorry. Sorry about that. So monitoring of a CCP is the act of conducting a planned sequence of operations or measurements to control parameters to assess whether the control measure is under control or not. For this case, you need to tell us what are you monitoring. You need to also tell us when are you monitoring. You need to tell us who is monitoring and what is being monitored and how are you going to monitor it. And for this case, if it is pasteurization, what are you monitoring? Temperature and time. How are you going to measure? Using an in-field thermometer, or even using a thermometer and a timer. When are you monitoring? After every patch. Who should do that? The line operator. Those are what refer to as establishing a monitoring system. 3WH. What, when, who, and how. Kindly know that. Principle number 5, you establish the corrective actions. What actions? Maybe, for example, now you've checked and you've realized that a particular step does not fall, or a particular step is not in line with the parameters. It has exceeded the limits. So what do? You take action. You control that step. So anything, for example, if it is, for example, pasteurization, you might decide to do what? Repasteurize. That can be one. Number 2, another corrective action can be disposing. You see? Disposing the affected product. Those are the ways in which you can be able to establish corrective actions. And not only that, if you do something, for example, if it is temperature which is not okay, you do what? You adjust the thermometer and confirm the thermometer if it is working as intended. Principle number 6, you validate. And finally, validate is just, I'm not going to talk about. This one is going to come out very clearly when we'll be dealing with the real hazard plan. Number 7 principle is documentation. You need to keep the records, documents, forms, procedures, and work instructions. Anything that you need, you just record them. Tell me this record is needed, this record is there, and you should keep those records. And examples of the Haccp records you need is maybe, for example, composition of the Haccp team, the list of that team, and maybe their qualification, the list of the hazards, and maybe as a hazard analysis supporting the scientific evidence and their relevance, determination of the CCPs, the critical limits that are there, validation of Haccp control measures, and the training needs that you might have identified. You can also have the SOPs as part of the documents that you need to keep. Example of the records you can be able to keep is the minutes, the monitoring records from the CCPs, and any reports of visual inspection and trainings performed. All of those are examples of the HACCP records you can be able to keep. Finally, this is how the HACCP plans will look like. This, at the end of the day, this is how the HACCP plan will look like. You'll have number one, the CCPs. You need to identify the critical control steps. For example, maybe you have one or two steps which falls under CCPs. Maybe one is pasteurization. Come to so it's just right step is pasteurization. Number two, significant hazards. State the hazards that can be there in pasteurization. Tell me biological hazards, chemical hazards, which you will have done. Come to the limits. For example, if it is temperature, tell me the limits. Maybe 72 degrees Celsius for 30 minutes, or maybe 85 degrees Celsius for 30 minutes. Monitoring. What are you monitoring? How are you going to monitor? When and who is going to monitor? Corrective actions. What actions can you do if you monitored and you found that you are not working according to intended use, according to intended procedures? You need to now have the correcting actions. You verify the activities, and finally, you indicate the records that you have been able to keep. Having said that, ladies and gentlemen, it brings us to the end of the theoretical part of the HACCP thing, and ushers us to the next phase, which is the practical aspect. We now need to deal with a practical example of a HACCP plan. We need to develop a HACCP plan from scratch with you people, because the essence of this training is to ensure that each and every one of us gets the best knowledge as far as possible. Having said that, ladies and